Good morning, students. Chapter 5 Laws of Motion continue. Yes, it is last lecture of chapter 5. Okay, we will see some questions, and after that, from next day, we will start a new chapter, that is work energy power. Okay, see here. Figure shows an arrangement in which the pulleys are smooth and strings are of negligible mass. For the system to remain in equilibrium, the angle theta should be, you have to find what is angle, yes, you are given one figure, see here, two pulleys, frictionless pulley, these strings having negligible mass, and yes, you are given three blocks, m, and root 2m, its mass is m, its mass is m, and its mass is, it is root 2m, and yes, this angle is theta. Your question is, if the system is in equilibrium, you have to find what is angle theta. Clear about this? Okay. So now, how to find? First of all, in this system, we have to draw forces, free body diagram. Okay. See, what are forces? First of all, on this block M, in downward direction, there is force mg. Okay, again on this block in downward direction there is weight mg. Again on this block in downward direction that is weight root 2 mg. So under the effect of these three weight, these all strings are under tension. These all strings are under tension. Now that one main question. Okay. Yes, why T is same? Because see, these strings are massless, and yes, see, this string is whole as one connected. So yes, tension in this string is same. But why this side or this also T? Because see, this system is symmetric. This mass is m, this mass is m. This mass is root 2m. Yes, if this angle is theta, then obviously this angle is also theta. So yes, if tension produced in this string is T, then again tension produced in this string is also T. Clear about this? Okay, so yes, that's why I have considered tension in this string as T and also tension in this string as T. Clear about this? Now, this mg and T in vertical plane. But here, this root 2 mg is in vertical plane, but this T and T tension, they are not in vertical or horizontal plane. So obviously, we have to resolve this two T, means this two tension in two components, one in horizontal direction and one in vertical direction. Clear? So see, we will resolve these two T, we will resolve these two tension. How to resolve these two tension? See, here it is. This T, we will resolve in two components, one in horizontal direction, one in vertical direction. Any doubt? Okay. So yes, as T is making angle theta with this component, it becomes T cos theta, and it becomes T sin theta. Any doubt? Okay. Again, this T, we will resolve this T in two components, one in horizontal direction and one in vertical direction. So again, T is making angle theta with this component, so it becomes T cos theta, and it becomes T sin theta, Clear about this? So yes, it is figured, and yes, this whole system is in equilibrium. So how to solve this question? See, first of all, I will consider this block only this block. Okay. So see, as system is in equilibrium, I have to consider that first block, mass m, in downward direction force acting is mg, and in upward direction force acting is T. And yes, as it is in equilibrium, we know that for equilibrium sigma f is equal to 0. So yes, there is only vertical direction. So yes, we can write sigma fy is equal to 0, and sigma fy is equal to 0. It means here T is equal to T is equal to mg. It is T is equal to mg. Equation number 1. T is equal to mg. It is equation number 1. Any doubt? Any doubt? Okay. Now this block is in equilibrium. So this block is also in equilibrium, and for this it is same condition. Now what about this block? What about this block? See, I will draw this block. See, having mass root 2m. Having mass root 2m. On this block, in downward direction, force acting is its weight, that is root 2 mg. Yes or no? Now, yes, this 2 tension, but I have resolved this 2 tension into components. See, one component in this direction, it is T sine theta. Another component in this direction, it is T sine theta. And these two components, T cos theta plus T cos theta, it will act in upward direction, that is 2T cos theta. That is 2T cos theta. Any doubt? Any doubt? Okay. So yes, for this block is also in equilibrium. This block is also in equilibrium. Then how to write for equilibrium? Okay. For equilibrium. For equilibrium. Yes, we know that for equilibrium, sigma f is equal to 0. Yes, we know that for equilibrium, sigma f is equal to 0. For equilibrium, we know that sigma f is equal to 0. Yes, sigma f is equal to 0. So yes, we know that sigma fx is equal to 0, and also sigma fy is equal to 0. So see, sigma fx in this direction. Yes, there are two forces acting, T sine theta and T sine theta. Yes, their magnitudes are equal and direction is opposite. So obviously, these two forces will cancel out each other. These two forces will cancel out each other. So yes, forces acting in x direction, the resultant is 0. Yes, the resultant is 0 because here it is T sine theta minus T sine theta. So obviously, it will become 0. Now what about sigma fy? Now what about sigma fy? Sigma fy is equal to 0. Sigma fy is equal to 0. Forces acting in this direction. In upward direction it is 2t cos theta. In downward direction it is root 2 mg. So yes, I can write 2t cos theta is equal to it is root 2 mg. Is equal to it is root 2 mg. Clear about this? Yes, 2t cos theta is equal to, here it is root 2 mg. Now we know value of t. T is equal to mg. Yes, 2. T is equal to mg, that is 2. Okay, cos theta is equal to it is root 2 mg. So see, m cut, g cut, okay, then cos theta is equal to it is root 2 upon 2. So yes, we can write cos theta is equal to it is 1 upon root 2. So yes, we can write theta is equal to, for which value? For which angle value of cos is 1 upon root 2? For which angle value of cos is 1 upon root 2? It is 45. It is 45. So theta is equal to, here it is 45 degree. Means if this angle is 45 degree, then the system is in equilibrium. Then this system is said to be in equilibrium. Clear about this? Okay. So yes, it is one question in which you are given two pulley system. Then yes, you have to find what is angle that is made by the strings with vertical in equilibrium. Clear about this? Yes, important is again, what is important? Important is this free body diagram. How to draw these forces? How to draw these forces? Here mg is in downward direction, so obviously tension is in upward direction. mg downward direction, tension upward direction. Root 2 mg downward direction, tension in upward direction. Clear about this? Okay, so yes, it is one important question. Theta is equal to 45. Now we will see another question. See, a block A of mass 20 kg is put on a frictionless surface and another object B of mass 2 kg is placed over it. The coefficient of friction between A and B is 0.25. First question. A horizontal force of 2 Newton is applied on B. Then calculate acceleration of block A and B and frictional force between A and B. Also, all these quantities again Find these quantities again, all these quantities again. If the force on B is 20 Newton, G is equal to 10 meter per second square. Yes, see, we will find this question. Here, a block of mass 20 kg, MA is equal to 20 kg. Mass of block B, MB, it is 2 kg. Coefficient of friction between them, mu S, is equal to 0.20. Okay. A horizontal force of 2 Newton is applied on B. First case 1. Case 1. See, a block A of mass 20 kg is put on frictionless surface. Yes, it is frictionless surface. It is frictionless surface. Block A having mass 20 kg, having mass 20 kg is placed on A. So yes, on this surface, when A is moving relative to this surface, when A is moving relative to this surface, there is no friction force between that. Okay. And another object of mass 2 kg, B, is placed over it. So yes, B is placed over it like this. Okay. And yes, as you are given the coefficient of friction between A and B, there is frictional force between A and B. There is frictional force between A and B. On this surface, yes, there is friction force. On this surface, yes, there is friction force. Clear about this? Clear about this? This surface is frictionless, but this surface is having friction. Okay, yes. What is first question? A horizontal force of 2 Newton is applied on B. Is applied on B. This F is equal to 2 Newton force is applied on B. Then you have to calculate what is acceleration of block A and B and what is frictional force between A and B. So, B, on B, force applied is 2 Newton. But there is one question. Due to this external force F is equal to 2 Newton, is there any relative motion between B and A? See, it is external force. We know one result, that if external force is greater than maximum static friction between two surfaces, then object will move relative to that object. Yes or no? Yes, we know that. Okay, so see, as this B is placed over A, this B is placed over A, I will find maximum static friction between A and B. Maximum static friction between A and B. So see, how to find? How to find maximum static friction? Maximum static friction between A and B, between A and B. Okay, understand? Between A and B, that is Fs maximum. That is Fs maximum. We know that what is equation of Fx maximum? It is mu s into n. But what is value of n? See, it is block A. See, it is surface. Yes, here it is. It is block A and it is block B. So yes, due to block B in downward direction, due to block B, it is B and A, diagonal one, right? Okay. Yes, in downward direction it is MBG, and in upward direction it is normal. Yes or no? Because A and B, this surface is their contact surface. This surface is their contact surface. It is it is B and it is A, and it is their contact surface. So yes, what is weight of block B? It is MBG in downward direction. So due to that, N is normal reaction, or we can say reaction due to A on B, reaction due to A on B, and that is in upward direction. Any doubt about this? Again, B block, its mass is MB, so MBG in downward direction. So Newton's third law of motion, this block will also exert some reaction on it, and it is N. Yes or no? Yes, it is. So yes, here we can say, as I want to find maximum static friction between these two surfaces, then as N I have to consider MBG. As N I have to consider mu s, it is MBG. What is value of mu s? You are given 2.25. MB, it is 2. And what is value of G? It is 10. It is 10. Okay, clear about this? So yes, 0.25 into 10, it will be 2.5 into 2, so it is 5 Newton. It is 5 Newton. So maximum static friction, Fs maximum, is equal to, it is 5 Newton. So here external force applied on B is 2 Newton, which is less than maximum static friction. So here applied external force F is equal to 2 Newton is less than Fs maximum, that is equal to 5 Newton. Clear about this? So there is no relative motion. There is no relative motion between. There is no relative motion between A and B. There is no relative motion between A and B. Means this B will not move. This B will not move on A. There is no relative motion between them. There is no relative motion between them. Clear about this? Clear about this? Okay, so yes, there is no relative motion between A and B. There is no relative motion between A and B. But as this surface is smooth, under the effect of this force, 2 Newton, there is no relative motion between A and B. But as this surface is smooth, under the effect of this force, these two blocks will move together. These two blocks will move together. Clear about this? So yes, due to force F is equal to 2 Newton, as surface between A and surface is smooth, A and B will move together. A and B will move together with same acceleration. Clear about this? Then how to find their acceleration? As they are moving together, their acceleration A is equal to force upon NA plus NT is equal to, what is force? Yes, what is force? Force is 2 Newton divided by what is total mass? It is 20 plus 2. So yes, here it is 2 by 22. So yes, here it is 1 upon 11. So acceleration is, yes, it is 0.09 meter per second square. It is value of acceleration. Clear about this? Okay. So yes, when 2 Newton forces applied on B, as frictional force, maximum static friction between A and B is 5 Newton, there is no relative motion of B with respect to A. There is no relative motion of B with respect to A. B will not move on A. Clear about this? Clear about this? Yes, but as this system is smooth, these two blocks will move together. These two blocks will move together. Clear about this? Clear about this? Okay, so yes, it is first question. Now, what is second question? What is second question? Case 2. What is second question? That is case 2. Again, these two blocks. It is block A, it is block B. Okay, and now force applied is 2 Newton, and now force applied is 2 Newton. Okay, so yes, sorry. In first case, force applied is 2 Newton. Now in second case, force applied is 20 Newton. Okay, now force applied. Now force applied on block B is 20 Newton. Yes. Okay, force applied on block B is 20 Newton. And yes, 20 Newton, F is equal to 20 Newton is greater than Fs maximum, that is 5 Newton. So yes, B, between B and A, between B and is relative motion. There is relative motion. There is relative motion. Clear about this? Clear about this? So yes, when force applied on block B is F is equal to 20 Newton, so which is greater than Fs maximum, that is 1 Newton. So between B and A there is relative motion. There is relative motion. Okay. Now I will draw free body diagram of block B and A like this. Again, you are given system like this. It is block A. And yes, it is block B. On block B, F is equal to 20 Newton is applied. Yes or no? So see, I will draw here free body diagram for object A and B. First of all, for object B, due to B, as its mass is mb, it is acting always mb in downward direction. Due to B, mb is always acting in downward direction. Yes or no? Yes, there is contact surface. Yes, there is contact surface. So normal reaction is acting in upward direction. Yes or no? Yes, it is. On B, force F is applied in this direction. Force is applied in this direction. That is F is equal to it is 20 Newton. Yes or no? So yes, friction force is acting in this direction, and yes, it is nothing but Fs maximum. It is Fs maximum. Clear about this? And yes, under the effect of this, as force is applied in this direction, and now as there is relative motion between A and B, I am assuming a block B is moving with acceleration AB in this direction. Block B is moving with acceleration AB in this direction. So yes, as block B is moving with acceleration AB in this direction, now acceleration will be different. Why different? Because A and B, they are moving with respect to each other. Okay, in first case, they are moving together. They are moving together. So their acceleration is same. But in this case, their acceleration will be different. So here, it is free body diagram for block B. How to write? Sigma F is equal to it is mb AB. Sigma F, forces acting in this direction, it's in horizontal direction. Okay, in this horizontal direction, forces acting are in, yes, it is 20 Newton. Fs maximum is 5 Newton. So we can directly write it is 20 minus 5. What is value of mb? That is mass of block B. Yes, mass of block B is 2 kg. And we have to find it is kg. So 20 minus 5, 20 minus 5, it is 15. 2 AB. So yes, AB is equal to it is 7.5 meter per second square. It is 7.5 meter per second square. Clear about this? Okay. Now what about A? What about A? See on A. First of all, MAG, that is always acting in downward direction. Now A is in contact with two surfaces. A is in contact with two surfaces. Yes or no? So there are two normal forces. First, due to B, it will be in downward direction. It will be in downward direction. So yes, it is N. Why N? Because see, A exerts normal force on B, N. So also B exerts normal force on A, it is N. Clear about this? So this normal force is due to B. Now, due to this surface, what is normal force? It is in upward direction, that is left hand dash. Yes or no? Now, is there any horizontal force on A? No, it is only on B. It is only on B. But yes, as there is friction force between A and B, when two objects are in motion, there is opposed to their relative motion. So if on block B, friction is in this direction. On block A, friction it is in this direction. That is 5 Newton. Okay, and let under the effect of this, block A is moving with acceleration AA in this direction. So sigma F, here it is MA, here it is MA, and here it is A. Clear about this? Sigma F in this direction, there is only one force, that is 5 Newton. So 5 is equal to MA, mass of block A is 20, and here it is A. Clear about this? Okay, so yes, how to find acceleration A? It is 5 by 20, means it is 1 upon 4 meter per second square. Clear about this? So yes, it is a question in which there is relative motion between two blocks. Case 1, force is 2 Newton. Case 2, force is 20 Newton. In first case, external force is less than maximum static friction. no relative motion between A and B. But as lower surface is smooth, they both will move together with same acceleration. In second case, external force is greater than maximum static friction. So yes, there is relative motion between A and B, and their acceleration is different. Clear about this? So what is difference between these two questions that you have to understand?